Welcome to Video 6 Notes, Solving Multi-Step Equations. This is our second day, and we're going to review the steps, and we're also going to look at some unique cases. Thanks for having what you need, and let's get started. The first step is always to look to see if you need to distribute, so please underline that or highlight that. All right, and then it says step 2 is simplifying, and you're looking to see if there are any like terms on either side. Then you're looking to see if you can combine terms across. And so we're going to use properties of equality to do the same thing on each side. And we do the opposite operation to move it across. So I wrote myself a little note like move across, question mark. And then we're just using adding and subtracting to move things across the equal sign. And then once we've moved things and we just have something x equals something, we're going to either multiply or divide. Most of the time divide, but multiply or divide to get that x by itself, and then we can check our solution. Let's get started with some examples. All right, and here's just a little chart of inverse operations, and the key is to look closely and decide what operation is happening, because it's pretty easy to know what the opposite is. This is a nice chart for you. All right, this first one. I see parentheses, and so I'm going to distribute. The key is to copy down the original equation, but distribute that 7. And so I'm going to write down that original 7k, so go ahead and write down the original 7k plus 7 times 2k's is 14k's. I'll line those up. 7 times a negative 9, and that's a negative 63. Now, when we multiply, when you get a negative, it says plus negative 9. When I get a negative number, I'm just going to simplify the whole thing out and say, I have a negative 63, so I'm taking away 63. So you don't have to put plus a negative 9 or plus a negative 63. Just do minus 63. And there's no like terms on this side, so I'm just going to recopy those, okay? The next thing is to look to see if step 2 is, are there any like terms on either side? And there are like terms over here, and I've marked them up. I always mark up my like terms. 7k's and 14k's is 21k's. And then it's sort of a pain, but we do this. We'd rather have you do quality over quantity. We're not asking you to do a lot of problems. Copy down the equation as it was. All right. And now we don't have like terms on either side, so we have to start moving. And so I'm going to move this 4k first, just by subtraction. Minusing 4k on both sides. A lot of people like to cross that off, and you are welcome to do that because you're zeroing it out and you're subtracting from both sides, so you're not changing the equation, you're just moving something over to the other side. And so we get 17k's then, minus 63 equals negative 148. And so then we need to get the k's by themselves, so we add 63 to both sides. Let me write that down, and again, some people like to either make that a 0, help them remember that you're zeroing it out, or people like to cross it out. Either way, just make sure you're not using that anymore. You just have the 17k's on the left side and the equal sign. I've kind of kept my equal sign kind of lined up here. And then I use my calculator, negative 148 plus 63, and I get negative 85. And then the last step is the fourth step there up there at top. It is to divide by 17. All right. And when I divide by 17, I can carefully do it in my calculator, negative 85 divided by 17, and I got a negative 5. Now we can make sure that we're correct, and you can check this out. I'm going to show you this once, and you can do it anytime, and every time is great, taking our time to do that. So when I wanted to check it, if I think my answer is negative 5, one single number is the only number that works in this to make both sides of this equation equal, is the negative 5. So I'm going to check that. All right, and so where where I have the k's, where these highlighted k's are, I'm replacing them with negative 5s. So I'm just typing in, and I'll type in my calculator. I'll do it with you. Let's just check it here. Let me move my, there we go. And I'm going to type in 7. I'm going to type in each side, parentheses, negative 5, parentheses, plus 7. Now be careful, I'm going to do it just the way it looks. Parentheses 2, parentheses, and negative 5, closing the parentheses around that negative 5 because I'm substituting that in, plus negative 9. I'm typing it in exactly the way it is. I could do minus 9 as well. And I got a negative 168. Now the other side should be a negative 168 if I am correct, if my answer is correct. So negative 148 plus 4 times negative 5. and we should have a negative 168. So I know for sure that I am correct in knowing that the only number for that letter K, that variable K, is negative 5. That's the one that makes it equal. There's one solution, and we found it. All right, now I'm going to show you some problems you're going to see in Get More Math, and they're going to ask you to tell not the answer, but how many answers there are. Just like that last one had one answer. All right, and so this next one, go ahead and check this. There's going to be one solution. All right, and you can't just check it off right away. You got to show the work and make sure that you know it's going to come up with one answer. I'll give you some hints about how you can make this a little shorter here. So look at this first problem. I rewrote it over here on the right because you got to show your work on this. So I'm going to distribute. So draw your distributing lines on the left, and notice there's no distributing on the right. There's like terms though, so I underline them in blue and double line of red. And so I'm going to do those all in one fell swoop here. If I distribute, I get negative 6x, and then 3 times negative 1 is minus 3. Notice I made it a minus 3, equals a negative 9 plus 4, and I can use my calculator, negative 9 plus 4. I don't type in the x, I just want to know how many x's there are, and it's a negative 5x, and then negative 2, take away 2 more. I could do that in my calculator, negative 2 minus 2 equals negative 4. So now I've got a simplified equation. They're not matching up or anything. I'm going to have to move some x's, so I'm going to move the 5x's. You can do either one. You could have done plus 6x's. I just moved the 5's, and these cross out, and I have left over on the side negative 6x plus 5x is negative 1x. I bring down the 3, and I bring down the negative 4, and I'm not done. I need to get the x by itself, so I'm going to do the opposite operation of equality, and I'm going to add 3 to both sides, and I'm going to get negative 1x equals negative 1. And when I divide by negative 1 to get the x by itself, my answer is 1. Just happens that the only answer that works for x is the number 1, and there's one solution. That's proving that there's one solution. When I could have stopped right about here if I'm trying to answer this question. I know I'm going to get an answer for x because I have an x value, and I'm going to get a calculation. So that you could have stopped here at this orange line, because you'll know you're going to get an answer, all right? And that'll make more sense when we go to the next one, all right? So let me show you this next one. The next one happens to be if everything matches up. So please check infinite solutions. There's two ways to describe infinite solutions. This means any number. You could pick any number to substitute in and it will work. It will be an answer. It's a possibility. And that's because both sides actually match. And you can stop when you see both of them matching up because you know any number will work. It's also called an identity. So highlight all those things. So we're looking for we're going to call this answer an identity or infinite solutions because we don't just have one single number that works. And so I've written this problem up over on the right-hand side for you. And if you could just draw the distributing lines. And also, again, there are like terms, so underline the x's and somehow mark up or circle the constants or plain numbers there. And let's just write out what happens. 7 times 6 is 42, 7 times 7 is 49. And then 53x's minus 11x's is 42x's. And then when I do 6 plus 43 on my calculator, I get 49. Now that's an exact match. When you can, if you distribute and you combine and you see this, you can say like they match exactly. There's not going to be one single letter or number that works. There's going to be any number will work. If I put a 5 in here and I put a 5 in here, both sides are going to equal. You can stop there. Sometimes you can put this down if you want. Sometimes we just automatically start moving the x's because that's what we do when we solve, right? So look what happens. When you subtract the 42's off, they both go away, and you get 49 equals 49. So it's still a match. It doesn't make sense. So this helps, though, know that, oh my gosh, they're exactly matching, and that's going to be infinite solutions. Any number will work when I put it in the original problem. So that's infinite solutions, when both sides match. And it's this line right here that's really, you can see that it's infinite solutions. And then one more, all right, is when things don't match up. and when we have no solution. So if no number would work, so you try to solve this and absolutely no number you could substitute in, no number exists, and so it's no solution. And what happens is that the variables cancel and things don't match, all right? So take a look at this problem. So mark it up as no solution. This is what it's going to turn out to be, so that there's no possibility when we go to solve this. So again, you're going to be distributing on the left and then combining like terms on the right. So -4 times -7x is 28x's, and then plus 28 when I distribute a -4 times a -7. And then again, when I use my calculator, I'll type in -32 plus 60, and I got 28x's. But when I add these two like terms, I only get a 2. All right, so these don't match, all right? And so I might keep going. A lot of us do keep going. I subtracted 28x off, but I notice that they are gonna go away. Like this cancels and this cancels, right? Those make 0, and I have 28 equals 2, and in no world does 28 equal 2. And I would actually put this notation in my work. So there's no way they're gonna match. There's no x value that I could put in on this side and this side that would make this side equal the same as the other side. So no number works when they cancel out, when the variables cancel and my numbers left with are different. It means there's no possible solution. So there's no matching at all, that's no solution. There's exact matching, that's an infinite solutions. And there's when I actually solve and get a variable with one answer, not the number one necessarily, but an answer. That means I do have only one solution. Thanks so much.